Welcome back to First at 4. I'm meteorologist Jacob Morse here on the road at the National Weather Service in Bismarck, taking a deep dive into how weather balloons are launched and the very useful applications of the data that they collect. Last week we showed you how the balloons are prepared to be launched, and now we have our latex balloon inflated with hydrogen with the parachute attached to a string 6 feet below that. 75 feet farther down is the radiosonde, which is the instrument that measures temperature, dew point, and GPS coordinates as the balloon travels about 20 miles up in our atmosphere. Weather balloons are launched twice per day at hundreds of locations around the world, including by 68 weather forecast offices across the contiguous U.S., allowing meteorologists to get a snapshot of the current condition of our atmosphere.
It's more of kind of like a temperature measurement that you would see from your normal thermometer, but aloft. And it also measures, like I said, humidity, and it measures, pressure and all that kind of stuff. So we are able to kind of build a bigger 3D picture of what is happening real time.
We're launching this weather balloon at 6 p.m. so that the data has enough time to be ingested into the next update of our weather forecast models. The balloon needs to be launched at these specific times, even in high winds or in a blizzard.
There are times where we have launched in 50, 60 mile an hour winds, so it is pretty brutal. So the only conditions it would be if we couldn't launch a weather balloon would be in a thunderstorm. We generally try to avoid launching in thunderstorms just due to the lightning issue and you having a hydrogen balloon, but also the fact that if you launch the balloon in the thunderstorm, it could corrupt your data as well with the updraft, so you're not getting proper representation of the atmosphere. It's kind of skewed based off of the thunderstorm.
One final thing needs to be done before the launch.
We have to call the Bismarck Tower to make sure that we are cleared to launch the balloon because we are close to the airport and we don't want to interfere with any international flights. So they have to give us an okay for us to launch the balloon. So what I do is I walk out far enough away from the building where it's not going to interfere with the balloon, and then we kind of just let it go.
Now that we have a successful launch, the balloon will rapidly travel up, with the first 25,000 feet or 20 minutes of the flight being the most important, since this is where most of our weather happens. However, the balloon will continue to travel into the stratosphere before popping once the balloon reaches about 25 feet wide. The balloon can also drift for more than 125 miles from the release point, depending on the prevailing winds aloft. However, in calm winds, weather balloons can stay pretty close to their launch point. Once the balloon bursts, the radiosonde returns to Earth via the parachute, and radiosondes can be sent back to the National Weather Service by mail.
I think they said about 10% get returned to maybe 5%, so most of them end up in people's fields, or they're all biodegradable, so even the parachute, everything will eventually break down, and it's good for the environment. But it's just more of kind of a launch and forget system, just based off of cost. It'd be hard to retrieve all of these.
Back inside, we can start to see our data coming in from the balloon.
So this right here is our SKU-T. We have our temperature profile right here, followed with our dew point, and that's kind of how we see the stability of the atmosphere, and we're kind of able to plot and track and see if the environment is stable or unstable.
This is the completed SKU-T diagram from our launch on May 21st, with temperature in red and dew point in green from the surface to tens of thousands of feet up. The temperature lines, which I've highlighted in black, are slanted, and other lines on the chart help meteorologists to judge how quickly temperatures are changing vertically in our atmosphere. When the lines are closer together, there's more moisture in that layer of the atmosphere, allowing for clouds to form there. Most of the balloon's flight is below freezing, as shown with the area shaded in light blue. Temperatures normally decrease with height in our atmosphere, but when the temperature line moves to the right on our chart, this indicates temperatures are increasing with height, called an inversion, which is a stable layer of the atmosphere. Wind speed and direction data is derived from the GPS coordinates of the radiosonde, and these are plotted as well as the balloon ascends. These SKU-T charts are invaluable for meteorologists, especially when assessing if conditions are favorable for severe weather. That's why these weather balloons need to be launched twice per day, 365 days of the year, to get accurate data of what's actually happening thousands of feet above our heads. That's it for this deep dive series into weather balloons launched by the National Weather Service. We'll send it back to you in the studio, Jody and Kevin.
A lot of great information there.
Yeah.
And looking at those SKU-Ts as a meteorologist, that it gives us everything we need on one sheet of paper, so to speak, to give us an idea how unstable the atmosphere is. You saw CAPE, you saw some other indices there, and that's kind of how we start our day as meteorologists, figure out how stable or unstable the atmosphere might be.